Okay friends, so today we are going to discuss three-dimensional geometry, lines in space. Now before we proceed with this particular chapter and solve problems on that, we need to understand some important results from the vectors which I have listed here. So please go through the results. You can just read them. I'm keeping them here for you. So take a good look at these results. You know all these results from your standard 11 chapter on vectors. It is just a refresher of your memory. Now please note that this is one very important result. We will be needing that quite often. Also this one is another important result that also we will be needing quite a lot. Let us go to the next page. If three vectors are coplanar, then their scalar triple product is 0. This is another extremely important result that we will be using very often. Then we know about direction ratios and direction cosines. So I've just listed the result. Okay, now let us go ahead with the concept of lines. If you want to draw a line, what do we need? If you want to draw a line, then we need I 2 points, right? We need 2 points. So suppose one point is here and another point is here, then yes, we can draw a line. So in order to draw a line, we need minimum 2 points. Or there is another situation in which we are given a point and a vector. Suppose we are asked to draw a line passing through this point and parallel to this vector, then yes, we can do that. We can draw a line which is passing through this particular point, say A, and it is parallel to this vector P. So in this way we can draw a line either through 2 points or through a point and a parallel vector. So in this way we can go ahead and let us try to understand now how to find the equation of line in a three-dimensional space. Suppose this is a point, say x1, y1, z1. This is a vector b bar, say b1 I bar plus b2 j bar plus b3 k bar. Now we will draw a line parallel to b bar, and let us take a point r x y z, which is any point on this line. Then the vector ar and b bar are parallel, and we have seen in the previous result that if two vectors are parallel, then one of them is a scalar multiple of the other. So we can have ar equal to lambda b bar, where lambda is any real number. It can be any real number, 2, 5 by 7, minus 8, 3 by 29, root 5, whatever. Now ar bar is obviously r bar minus a bar. So what we get is r bar minus a bar equal to lambda b bar, or r bar equal to a bar plus lambda b bar. This is known as the vector form of equation of line, where what is r bar? R bar is xi plus yj plus zk. What is a bar? A bar is x1i plus y1j plus z1k, and b bar you already know, it is b1i plus b2j plus b3k. So in this way we can have the vector equation of line, which is r bar equal to a bar plus lambda b bar. Now let us see the Cartesian form of the same equation. We are going to see the Cartesian form of the same equation. Let us start with the vector form. R bar minus a bar equal to lambda b bar. What is r bar minus a bar now? It will be x minus x1 I bar, right, plus y minus y1 j bar plus z minus z1 k bar. This is lambda b1 I bar plus lambda b2 j bar plus lambda b3 k bar. Now equate to coefficients of I bar, j bar and k bar. What you will get is x minus x1 is lambda b1, y minus y1 is lambda b2, and z minus z1 is lambda b3, so that x minus x1 upon b1 equal to y minus y1 upon b2 equal to z minus z1 upon b3, and this is equal to lambda, where lambda can take any values, any real values, and this is known as the Cartesian form of the line. X minus x1 upon b1 equal to y minus y1 upon b2 equal to z minus z1 upon b3 equal to lambda, where x1, y1, z1 is a given point, say 2, 3, minus 1, and b1, b2 and b3 are the direction ratios of a vector which is parallel to the line. So this is known as the Cartesian form of the equation of. There is one more form which you can see here, that is regarding cross product. If two vectors are parallel, then the cross product is 0 because sine theta is 0. You can see that if two vectors are parallel, then the angle between them is 0, and since the cross product is defined as a into b into sine theta, as sin theta is 0, their cross product will be 0. So that since AR bar is parallel to B bar, then we can say that AR bar cross B bar will be 0, that is R bar minus A bar cross B bar will be 0. So we have another form, R bar cross B bar minus A cross B bar equal to 0, or you can say that R bar cross B bar equal to A bar cross B bar. This is another form in which the equation of line can be written. So we have three forms. One is a vector form, other is a Cartesian form, and this is one more form in the form of the cross product. Now let us see a simple example. We are supposed to find equation of line which is passing through a point, say 2, -1, 3, and which is parallel to a vector 4i minus 3j plus 7k. So this is x1, y1, z1, and this is b1, b2, b3. So what will be the Cartesian form? X minus 2 upon 4 equal to y minus minus 1. So it will become y plus 1 upon minus 3, and this is z minus z1. So z minus 3 upon 7 equal to lambda. So equation of a line passing through a given point and parallel to a given vector is given like this. It's very simple. x1, y1, z1. So x minus x1 upon 4, y minus minus 1, so y plus 1 upon minus 3, and z minus 3 upon 7 equal to lambda. Where lambda is a parameter, it can take any values. Now let us consider a second example. Find the equation of line passing through 2 points, say A 4, 3, 8, and say B 2, -1, 6. Now obviously we have a situation in which this is a line, this is point A and this is point B. So obviously a vector which is parallel to the line is given by AB bar. So what is a vector parallel to the line AB bar? It is given by B bar minus A bar, which is 2 minus 4, so that is minus 2I bar, minus 1 minus 3, which is minus 4J bar, and 6 minus 8, that is minus 2K bar. I hope you understand. A vector which is parallel to the given line is obviously along AB, which is B bar minus A bar. So 2 minus 4, minus 1 minus 3, and 6 minus 8. So this is a parallel vector. Now x1, y1, z1, either you can take 4, 3, 8, or you can take 2 minus 1, 6. It makes no difference. So what is the equation of line? The equation of line can be x minus 4 upon minus 2 equal to y minus 3 upon minus 4 equal to z minus 8 upon minus 2, or the same equation, it will make no difference if you use x1, y1, z1 as 2 minus 1, 6. So the same equation can be x minus 2 upon minus 2 equal to y minus minus 1. So y plus 1 upon minus 4, and you can take the third point as 6, which is z minus 6 upon minus 2. Now minus 2 minus or minus 2, you can actually cancel the negative signs and you can make it plus all of them throughout. Still it is fine. Also you can take the ratio. You can see that 2 4 2 ka ratio, if you take simplest ratio, it can be 1 to 1 here also. It can be 1 to 1 here also. So you can divide throughout by a common multiple and you can still get the same answer. Since it is a ratio, you can divide by 2. So this is the equation of line passing through 2 points. First you find a vector along the line which is given by AB, and then we can go ahead with our regular procedure. So these are some simple equations of lines. Now let us try to go for some complicated problems. First of all, let us talk about different types of lines. What different types of lines will come across? See the first funda. If two lines are intersecting, then they are always coplanar. So let us understand this. In order to draw a plane, in order to draw a particular plane, we need 3 points. 3 points will constitute a plane. If we are given 3 points, we can draw a plane. So minimum points to draw a particular plane is 3. Now let us consider the situation of two intersecting lines. These two lines are intersecting. Now these two intersecting lines also form a system of 3 points. Let us see how. One point is the common point. Another point will be on this line in order to define this particular line, and one more point will be on this line to define the second line. So two intersecting lines basically make 3 points, and that is why these two intersecting lines, that is 3 points, will always be coplanar. So if we want to consider two intersecting lines, it is as good as saying that these two lines are coplanar. So intersecting lines are always coplanar. There can be another situation in which the two lines are parallel. Now please see, these two parallel lines also constitute a system of 3 points. To draw one line, we need 2 points, and to draw a third line we need only 1 point, because through this point we can draw a line parallel to the given line. So if two lines are parallel, again it is a system of 3 non-collinear points, and again they will always lie in a plane. So what we have studied here is that if two lines are intersecting, they are coplanar. If two lines are parallel, then also they are always coplanar. So two parallel lines as well as two intersecting lines have to be coplanar. Now there is one more situation which is known as skew lines. What are skew lines? Skew lines are not coplanar. They are lying in different plane. They are not coplanar. They lie in different planes. Let us illustrate this with the help of the example of a cube. Let us consider a situation like this. Say this is one plane and this is second plane. There is a line in this plane and there is another line in this plane. You can see that these two lines will never intersect each other because they are lying in different planes. Such lines are known as skew lines. For example, a line in this plane like this and a line in this face like this, they will never intersect, and that is why they are known as skew lines. Now please understand, if you consider this edge as a line and this edge as a line, Please note that these two lines are coplanar because this particular plane is constituting these two lines. So even though you may feel that one line is in this plane, other line is in the below plane, it is not so. This particular face is a plane which I can draw passing through these two edges, and therefore these two edges are parallel and therefore they are coplanar. Similarly, this edge and this edge, don't think that this edge is in the plane above and this edge is in the plane below, because this particular face is also a plane, and this plane consists of these two coplanar lines, this edge and this edge, right? But let me draw it again. Look at this situation. One line is like this, the other line is like this. They will never intersect and they are in different planes. So such lines are known as skew lines, S-K-E-W. So what are different types of lines we have seen? The different types of lines we have seen is, number one, intersecting lines. They are always coplanar. Number two, parallel lines. They are also always coplanar. And number three is skew lines. They are not coplanar. So these are the different types of lines that we are seeing. Now let us take an example. Find the value of lambda. This is a problem that is given to us. Find the value of lambda if the following lines are planar. Find the value of lambda if the following lines are coplanar. See, the lines are given: x minus 2 upon 1 equal to y minus 3 upon 1 . Excuse me. So minus 4 upon minus 4, and the second line is x minus 1 upon k, y minus 4 upon 2 equal to z minus 5 upon 1. So we are supposed to find the value of k for which the lines are coplanar. sorry, this is upon minus k. Now please see, these lines are coplanar. It means that the line entirely lie in the particular plane. So suppose this is a plane, and in this plane both these lines lie. So the point 2, 3, 4 lies on this plane, which is a point belonging to this line. The point 1, 4 and 5 also lies in the plane. Also the vector 1, 1 and minus k and this, don't confuse with k and k bar, this vector, also k to 1, this vector, entirely lie in this plane. So we have got three vectors. One vector is the vector which is joining these 2 points. Second is the vector which is parallel to the line, and third is a vector which is parallel to the line. All of them lie in a plane. They are parallel. So the triple product of this vector and this vector must be 0. Right? Because if the lines are coplanar, it means they are intersecting. They lie in the same plane. And if the lines lie in the same plane, then the points also lie in the same plane. And a parallel vector also lies in the same plane. So that we have got 3 vectors whose triple product can be taken as 0. So let us see which are these 3 vectors whose triple product can be taken as 0. First is this vector, obviously 2, 3, 4 and 1, 4, 5. So 2 minus 1, that is 1. 3 minus 4, minus 1, and 4 minus 5, which is minus 1. This is one vector. Second vector is I, j and minus k. So 1, 1 and minus k. What is the third vector? The third vector is k, 2, 1. K, 2, 1. The determinant must be 0. I leave this calculation to you. Just solve this determinant and you will get the answer. You will get 2 answers, that is k equal to 0 or k equal to minus 3. Please start solving this determinant. You will get a quadratic equation. On that basis you can very easily get this result. So I leave this very simple task to you. You can get this done and solve the answer. You will get k equal to 0 or k equal to minus 3. So this is a very important problem. If 2 lines are coplanar, then the find 3 vectors and the triple product of these 3 vectors will be 0. So in this way we can find the value of k. Let's move on. Now we are asked to find the nature of lines. It can be a question in as an MCQ. There will give you options. The lines are intersecting, the lines are coplanar, the lines are skew, lines are perpendicular. So the next question is find nature of lines. I am writing 2 lines here and we are supposed to find what type of lines they are. We have got x minus 1 upon 3, y minus 1 upon minus 1, z plus 1 upon 0, and the second line is x minus 4 upon 2, y upon 0 equal to z plus 1 upon 3. Now look at the parallel vectors. One vector is 3 minus 1, 0, which is 3i minus j plus 0k, and second vector is 2i plus 0j plus 3k. Are they proportional to each other? No. Since they are not proportional to each other, the lines are not parallel. Because if the lines are parallel, then one vector will be a multiple or proportional to other. So these two lines are definitely not parallel. Now let us see whether these lines are intersecting. If the lines are intersecting, then they must be coplanar, and if they are coplanar, again the triple product must be 0. So what are the points on this line? Let me do it quickly now. A point on this line is 1 1 minus 1. A point on this line is 4. Since there is nothing y, it's y minus 0. 4 0 minus 1. So what is one vector? The one vector is 1 minus 4, so which is minus 3i. Second vector is 1 minus 0, so j. Third vector is minus 1 minus minus 1, so 0k. This is one vector. Second vector is this parallel vector, which is 3i minus j plus 0k. And what is the third vector? 2 0 3. So 2i plus 0j plus 3k. So let us find the determinant now. Find determinant minus 3 1 0, 3 minus 1 0, and 2 0 3. You can see that if you multiply this particular vector by minus sign, this will become plus 3 and minus 1. It will not make no difference. These two rows are same, and therefore actually you can check the determinant. The determinant will be 0. As the determinant is 0, it means the lines are coplanar. They are of course not parallel. So lines are coplanar but not parallel means what? They must be intersecting. So what is the nature of these lines? These two lines are intersecting lines. Right? Let me quickly repeat this problem. Look at the direction ratios of a parallel vector. 3 minus 1 0 and 2 0 3 are not proportional. It means the lines are not parallel. Now we find whether the lines are coplanar. So one point on this line is 1 1 minus 1. A point on this line is 4 0 minus 1. So one vector is passing through these 2 points. So 1 minus 4, that is minus 3. 1 minus 0 is 1. Minus 1 minus minus 1 is 0. This is one vector. This is second vector. 3 minus 1 0 is second vector. 2 0 3 is the third vector. If the determinant of these three is 0, then the lines are coplanar. Coplanar lines are either parallel or intersecting. We have already proved that they are not parallel. It means they are intersecting. So the nature of these lines is that they are intersecting lines. Okay. Now we are coming to a little complicated part, which is shortest distance between two lines. There are two cases. Case number 1, the lines are not parallel. And case number 2, if the lines are parallel. First, let us consider a situation where the lines are not parallel. Now let us define two lines. Let us see the first line as r bar equal to a1 bar plus lambda b1 bar, and the second line is say r bar is a2 bar plus lambda b2 bar. Now please note that b1 and b2 are the vectors along the line. The shortest distance is always perpendicular distance. The shortest distance is always, obviously you can see that this is the one line and this is second line. Our shortest distance is the one which is perpendicular to both. Please note it is three dimensional. You will not be able to appreciate that this is a right angle, but since it is three dimensional, please understand that the shortest distance is always perpendicular distance. So which is a perpendicular to both the lines? You see the results page that we have seen on page 1. If you want to find perpendicular to between two lines, then we do the cross product. So line which is perpendicular to b1 as well as b2 will lie along the vector b1 bar cross b2 bar. So b1 bar cross b2 bar will be perpendicular to first line also. It will be perpendicular to second line also. Okay. Now suppose this is one line, this is second line. The point A1 is on this line and the point A2 is on this line. Then we can find a distance A2A1 and we want to find it along perpendicular. So we will do projection of A1 A2 bar along the perpendicular, which is b1 cross b2. Now what is projection of one vector on another vector? Projection of a bar on b bar is given by a dot b upon mod of b. This is the general formula for projection of one vector on second vector. So now we want to find projection of a2 minus a1, that is a1 a2 along b1 cross b2. So what will be the shortest distance? If you are not able to understand, just memorize the formula. That is the best thing to do for CET. So the shortest distance is given by a2 bar minus a1 bar dot b1 cross b2 upon mod of b1 cross. Please memorize this as a result. The shortest distance between the two lines is given by a2 minus a1 dot b1 cross b2 upon mod of b1 cross b2. This is simply a projection of a2 minus a1 on b1 cross b2. So this is shortest distance between two lines which are not parallel. Let us quickly solve an illustrative example to find the shortest distance. Find the shortest distance between the two lines. X plus 3 upon minus 3 y plus 7 upon 2 equal to z minus 6 upon 4 and x minus 3 upon 3 y minus 8 upon minus 1 so minus 1 upon 3. Now please see the parallel lines. Minus 3 to 4 is along one line, 3 minus 1 3 is along second line. They are not parallel because they are not proportional. So let us write down now what is a1, a2, b1 and b2. What is a1 here? 3, 7, minus 3, minus 7 and 6. You know x minus x1 is 3. So minus x1 is 3. So minus 3 minus 7, 6. What is b? What is a2? A2 is 381. What is B1 bar? Minus 3R plus 2J plus 4K. What is B2 bar? 3I minus J plus 3K. Now simply find, first we will find B1 cross B2, then we will find A1 A2 bar, and then we will put it in the formula. So please do the exercise. Find B1 bar cross B2 bar. I, J, K minus 3 to 4 then by I bar into 3 to the 6 minus also 6 plus 4, that is 10 I bar, minus into 3 is minus 9 minus 12, is minus 21 plus K bar into 3 minus 6. Please do it yourself, because I may make a mistake in doing the calculations. Please do it yourself. Let us check it again. 6 minus 4, that is 6 plus 4, 10, minus 9 minus 12. Okay, so this is B1 cross B2. And what is A1 A2? A2 minus A1. Three minus 3, so 6. 8 minus 7, so 15. And 1 minus 6 minus 7. So now we'll substitute in the formula. To get the result. So the formula is A2 minus 7, that is, I will not write IJK now, simply for the sake of simplicity, dot B1 cross B2 is 10, 21 minus 3, upon mod of B1 cross B2 will be under root of 10 square plus 21 square plus minus 3 square. So it is 6 into 10, 60. Plus 15 to 21 plus 21 upon so you can do the calculation and you can get the answer. So this is about the shortest distance between the two lines. Let us do one more sum on shortest distance. Find the shortest distance between the lines. Identify A1 and A2. A1 is 1, 2, 3. A2 is 2, 4, 5. So what is A2 minus 7? I plus 2j plus 2 minus 1, 4 minus 2, 5 minus 3. What is B1? 2i 3j plus 4k. What is B2? B2 is here. 3i plus 4j plus 5k. Let us do here B1 cross B2. Fifteen minus 16. 10 minus 12. 8 minus 9. So this is B1 cross B2 and this is A2 minus 7. Now we'll again put in the formula and we'll get the answer. It is A2 minus 7 dot B1 cross B2. So 1, 2, 2 dot minus 1, 2 minus 1 इनका dot product upon mod of this minus 1, 2 minus 1 should be 1 plus 4 plus 1. So 1 into minus 1 is minus 1, 2 into 2 is 4, 2 into minus 1 is minus 2 upon root 6. So the answer will be 1 upon root 6. Please take a good look. The answer is 1 upon root 6. What is the formula we have used here? Let me repeat. A2 bar minus A1 bar dot p1 cross b2 upon mod, that is the magnitude of p1 cross b2. This is the formula we have used for the shortest distance between two lines which are not parallel. Now let us see what if the lines are parallel. If the lines are parallel, then their b bar will be same, because since the lines are parallel, a vector along this line and vector along this line will almost be proportional, so it will be same. So the first line can be written as r bar equal to a1 bar plus lambda b bar. The second line can be r bar equal to a2 bar, but b bar will remain same. Now let us see the situation. So this is the point a1 and this is the point a2. So this is situation. We are interested in finding this distance. This distance we are interested in finding. A vector along the line can be taken like this. Say this is b bar. This particular line will be given by a2 minus a1. Suppose this is theta. Then this perpendicular distance which we want will be given by mod of a2 minus a1 into sine theta. So what we will do is, we want to find a2 minus a1 into sine theta, we multiply by b and we divide by b. B means magnitude of b bar. So a2 minus a1 का magnitude into magnitude of b into sine theta. This becomes a cross product between a2 minus a1 and b. So what is the shortest distance का formula in this case? The shortest distance का formula will be a2 bar minus a1 bar cross b bar upon mod of b. This will be the shortest distance if the two lines are parallel. So in case the two lines are parallel, this is the formula that we are going to use. So please memorize the formula. Even if you don't understand this, it is alright. Some of you will be able to understand it clearly, some of you may not be able to. But just memorize the formula. I am going to again rewrite both the formula. Case 1, if the lines are not parallel, then the shortest distance का formula becomes a2 bar minus a1 bar dot product b1 cross b2 upon mod of b1 cross b2. And the lines are parallel, then the same formula becomes a2 bar minus a1 bar, because b bar will be same if the lines are parallel. You can use any of the two b bars because they will be proportional upon mod. So this is the formula for shortest distance. Number 1, the lines are not parallel. Number 2, the lines are. Please memorize this formula, because in CET we don't have time to derive all this. So it will be necessary to memorize both the formulae for the shortest distance. Okay, let us do one more example and then we'll stop this session and go to the next session. Find the equation of line passing through the point 1, 0, 2 and which is perpendicular to the line x plus 1 upon 3 equal to y minus 2 upon minus 2 equal to z plus 1 upon minus 1. So what is the vector along this line? A vector on the given line is 3i minus 2j minus k. Our line is like this, which is perpendicular. There is a point on our line which is 1, 0, 2. So we are supposed to find a line which is passing through 1, 0, 2 and which is perpendicular to this line. Okay. Now suppose this point is A and let us take this point as P, which is a point on the first line, say is equal to lambda. So let us find the coordinates of this point P, which lies on this line as well as on this line. So any point on this line, you can see that if x plus 1 is equal to 3, then x plus 1 is equal to 3 lambda, then x coordinate will be given by 3 lambda minus 1. Its y coordinate will be minus 2 lambda plus 2 and the z coordinate will be minus lambda minus 1. Let us consider this as point P. So we have got coordinates of point P which are 3 lambda minus 1, minus 2 lambda plus 2 and minus lambda minus 1. So what will the vector AP bar? The vector AP bar will be P bar minus A bar. So let me write the vector AP bar here, which is P bar minus A bar. So 3 lambda minus 1 minus 1. So that will be 3 lambda minus 2 I bar. Second is this coordinate minus 0. So minus 2 lambda plus 2 minus 0. So minus 2 lambda plus 2 J bar, and this minus 2. So minus lambda minus 1 minus 2. So minus lambda minus 3 times K bar. Right? So this is the vector AP bar. So we know one vector which is AP bar and other vector which is B bar. Please note that this vector AP bar and this vector 3i minus 2j plus k, since they are perpendicular, their dot product will be 0. So now we are going to use the formula AP bar dot B bar is equal to 0. Let me erase a few. I think we have understood that AP bar dot B bar is 0. So I will not write ijk again. I will simply write the points. We can take the dot product. This is AP bar in front of your eyes. Three lambda minus 2 minus 2 lambda plus 2 and minus lambda minus 3 dot, this is b bar, 3 minus 2 minus 1, and their dot product is 0. So 3 lambda minus 2 into 3 plus minus 2 lambda plus 2 into minus 2 plus minus lambda minus 3 into minus 1. Their product will be 0. So what will you get here? Check it out. 14 lambda minus 7 equal to 0, and that gives you lambda equal to half. Right? That gives you lambda equal to half. Now what is point P? This is point P. You can go back and check. Okay. This is point 2P. Three lambda minus 2 lambda plus 1. Put lambda equal to half here. So the x coordinate of point P will be 3 by 2 minus 2. That will be minus 1 by 2. What will be the y coordinate? Minus 2 into 1 by 2 plus 2. That will be 1. What will be the z coordinate? Minus lambda minus 3. And that will be minus 7 by 2. So this is the coordinate of P. Minus 1 by 2, 1, and minus 7 by 2. So now we are ready with our line. If you recall the original diagram, it was like this. This was point A, which was 102, and just now we have computed point P, which is minus 1 by 2, 1, and minus 7 by 2. That gives me a vector along the line AP bar. So what is the vector along the line AP bar? P minus A. Minus 1 by 2 minus 1. think I made a little mistake in just find the points again. The point P was different. Sorry, you have got lambda equal to half, that is correct. Let us find the point P here. The point P is this. Let's quickly find the point P. Point P was this 3 lambda minus 1 minus 2 lambda plus 2 and minus lambda minus 1. So just put lambda equal to half in this. So the point P will be, put lambda equal to half here. Second is minus 2 lambda plus 2. And third point is minus lambda minus 1. And that gives you point P as 1 by 2, 1 and minus 3 by 2. So the point P is 1 by 2, 1 minus 3 by 2. Now the job is done. We know A and we know P. So we know the vector along AP. So what is the vector along AP? It is P minus A. So 1 by 2 minus 1. 1 minus 0, 1. Minus 3 by 2 minus 2 is minus 3 by 2 minus 2. You can multiply throughout by minus 2 and you will get the direction ratios of B bar as 1, minus 2 and 7. So that's it, and that is the end of the problem. Now we can get the equation of line. So what is your final answer? The equation of line AP will be x minus x1 is 1 upon the vector is B is 1 here, equal to y minus 0, you can write only y, upon minus 2, equal to z minus 2 upon 7. So this is our final equation of the line. So thank you so much. Don't forget to watch the next video. We will solve many more problems in the next video.